Question number 12 from the EOT. First question, find all values of x for which the tangent line to this function is at an angle of 45 with the x-axis, then again at an angle of 30. To solve this question, all you need to do is find f prime of x and put it equal to tan the angle that is given. This is the rule here. So this is the function f of x. If I were to derive it, I will get 3x squared minus 3 equal to tan the first angle given, which is 45. So here we are doing part A. Now tan 45 is in degrees here. So my calculator should be in degrees. So I will put tan 45 and I will get 1. So this means 3x squared minus 3 equal 1. Now I need to solve for x. Since this is a quadratic function, I will put everything on one side and the other side 0. So now minus 3 minus 1 becomes 4 minus 4 equal to 0. Now I will go to my calculator. I will click mod 53. I will factor this. A is 3, B is 0, C is negative 4. So I get 2 root 3 over 3 and negative 2 root 3 over 3. So x equal 2 root 3 over 3, 1 time positive, 1 time negative, and this is the final answer for part A. Now I do the same thing for part B, but now the angle is 30. So again I will write the derivative 3x squared minus 3 equal to tan 30. Now on my calculator, tan 30 is, again calculator on degrees because 30 is in degrees. If in the exam this was given in pi, put your calculator on radian. So tan 30 is root 3 over 3. And now I will solve this one. I will put this to the other side. So it becomes 3x squared minus 3 minus root 3 over 3 equal to 0. Now I will factor this one. Now all of this is a number. So all of this is your C. So now I will go to my calculator, mod 53. A is 3, B is 0. B is the term that comes with the x. There is no x here, just x squared. C is the number, which is all of this. So I will write minus 3 minus square root of 3 over 3. And I will click equal. I get 1.09 and minus 1.09. And that's it for this question. Now, question number 38. Find all the values of x for which the tangent lines to this and this are parallel and then perpendicular. Now, to solve this type of question, all you need to know that when we have two lines that are parallel, they have the same slope. So their derivatives are equal. So in part A, to find where two functions are parallel, all you need to know is find the derivative of the first function, put it equal to the derivative of the second function. Now, if you want to find where they are perpendicular, in part B, the rule says two functions are perpendicular if the product of their derivative is equal to minus 1. So you find the derivative of the first one times the derivative of the second one, that will be equal to minus 1. And this is the rule for this question. So solving part A, I need to put the two derivatives equal to each other so I can know where they are equal. So if I derive the first one, I will have 3x squared plus 2 equal 4x cubed plus 3x squared. Now I solve for x. Now notice 3x squared here, 3x squared here, they will cancel. I will end up with 4x cubed equal to 2. Divide both sides by 4. So x cubed is equal to 1 over half, 1 over 2, because 2 over 4 will simplify. and then I will take the cubic root of both sides. So x is equal to the cubic root of 1/2. Now in part B, now you will multiply both derivatives and put them equal to -1. So again, the derivative of the first one is 3x squared plus 2. The derivative of the second one is 4x cubed plus 3x squared. Multiply them together, equal -1. So now what are you going to do? You are going to expand these. So 3x squared multiplied by 4x cubed will give me 12x power 5. Then 3x times 3x squared, 9x power 4 plus 8x cubed plus 6x squared equal to -1. Now this type of function, if you put it on shift solve, the calculator will take a very long time to solve this one, and this is a power 5. So normal calculators cannot solve this. So this one would usually require a graphing calculator to solve this. Now how can this question be asked from me in the final? They can ask me which of the following equation will be used in order to find where the functions are perpendicular. One of the options could be this, that we multiply the derivatives and put them equal to -1. Maybe some other option will be something completely different. Maybe they add the function, put them equal to -1. So all you need to know is the rule. Or maybe they will bring for you some functions that are not to the power of 5. So the solving would be straightforward with the calculator. Now question number 39, find a second degree polynomial in the form of ax squared plus bx plus c such that we have these conditions. So there's part A, there's part B. Okay, starting with part A, the conditions are f of 0 is -2, f prime of 0 is 2, f double prime of 0 is 3. And they are telling me that the equation has the general form of this: ax squared plus bx plus c. Okay, I start from the very first condition given to me. F of 0 is -2. F of 0 is for the original function. So I say f of 0 is equal to what? I will substitute in every x 0, and I will put it equal to -2 because this is what is given. Now this is 0, this is 0, so I will end up with c equal to -2. So now we know what c is. Now we need to find a and b. So now we go to the next condition. Next condition, we are told that f prime of 0 is 2. So now this means I need to know what f prime of x is. So I need to derive this. Okay, a is just a number. So when I derive this, it will become 2ax plus b. Derivative of bx is b. b is just a number. So when you say what's the derivative of 5x, you will say 5. What's the derivative of 7x? You will say 7. What's the derivative of bx? You will say b, because b is just a number. Okay, so I found the first derivative. Now they are telling me that f prime of 0 is 2. So I will substitute in the place of x 0, and I will put this equal to 2. So this will cancel. So this means b is equal to 2. Now I need to find a. So now I use the third condition. F double prime of x or f double prime of 0 is 3. So I need to find f double prime of x. So this means I derive this again. What's the derivative of 2ax? 2a. What's the derivative of b? 0. Now f double prime of 0 is equal to 3. There is no x here for me to substitute in it. So this means f double prime of 0 is just 2a equal to 3. So this means a is 3 over 2. And now I can write the final answer that f of x is, I will write this, but then I will put the values of a, b, and c. 3 over 2x squared plus 2x minus 2. And this is the answer for part A. Now, coming to part B, we will repeat the same thing, but in part B, they told us different conditions. F of 0 is 0, f prime of 0 is 5, f double prime of 0 is 1. So now, we start with the general equation. We need to find A, B, and C. Again, we start with the first condition. F of 0 is 0. So if I substitute 0 in the place of all the x, this is 0 equal to 0. So C is equal to 0. Now I find f prime of x. So again, same like we did here, it will be the same thing. So f prime is 2ax plus b. Now they are saying f prime of 0 is 5. So if I substitute in the place of x 0 and equal 5, so this means that b is 5. Now f double prime of x is going to be 2a, and they are saying that f double prime of 0 is 1. So 2a is 1, so a is 1 over 2. So now I go and I write my final answer. Fx is going to be 1 over 2x squared plus 5x plus 0, or there's no need to write the plus 0, and that's it for this one. So this is part 1 of question number 12. I will continue the remaining in the next recording.